Hello everyone. So in this video, we'll continue with the topic consistency and replication in distributed systems. So in last video, we saw two data-centric consistency models, strict consistency and sequential consistency. And in this video, we'll be looking into linearizability, causal and FIFO consistency model. So starting with linearizability, in sequential consistency, the order of events is important, but the absolute time is somewhat irrelevant. So in all the replicas, in the same order, the event should be executed, but it doesn't matter at what time the event had occurred. While in linearizability, it is similar to sequential, but now the operations are ordered according to a global time. So a data store is said to be linearizable when each operation is time-stamped and the following condition holds. So the result of any execution is the same as if the operations by all processes on the data store were executed in some sequential order, and the operations of each individual process appears in this sequence in the order specified by its program. So this condition is same as sequential consistency model, while the extra condition that is added in linearizability is now each event is timestamped, and if the timestamp of operation 1 is lesser than the timestamp of operation 2, then operation 1 should precede operation 2 in this sequence. So let's understand linearizability using example. So in this figure A, you have four processes P1, P2, P3 and P4. They are performed, some events are performed on each process. So P1 is doing a write operation on X. Then P2 is in later point of time, P2 is doing a write operation on X, updating it to B. Then later on, when P3 is reading the same variable X, it is reading first B and then A. Okay, and in P4 also first the read operation which is happening, first it reads B and then A. That means in P3 the order of events was WXB and WXA. So first P2 happened and then P1's event happened. Same in P4. First P2 event happened and then P1 event happened. So this model is sequentially consistent, but it is not linearizability consistent. Because according to the linearizability, first WXA should have been executed and then WXB. Because the timestamp of WXA is lesser than WXB. So coming to the next example. So in figure B, again we have the same set of processes P1, P2, P3 and P4. Now on P1 is doing a write operation on X, P2 is doing a write operation on X, which is updating it to B. P3 is reading first A and B, P4 is also reading first A and B. That means the event of P1 occurred first and then P2. Here also event of P1 occurred first and then P2. Okay, the sequence is same in both, which is the first condition, and the timestamp of event which is lesser is happening first than the timestamp which is higher. So both the conditions are holding in figure number B. So this is both sequentially and linearizability consistent. So the difference between sequential and linearizability consistent is linearizability is weaker than strict consistency model but stronger than sequential consistency. While it is being useful, but it is not typically used because it is more difficult to implement. While sequential consistency is implementable, it is easy to implement, but it has poor performance. So to get around performance problems, weaker models that have better performance have been developed. So coming to the next consistency model, which is causal consistency. So the necessary conditions are writes that are potentially causally related must be seen by all processes in the same order. Concurrent writes may be seen in a different order on different machines. So causal is a weakening of sequential consistency model, and it makes difference or distinction between events that are causally related and that are not causally related. So if they are not causally related, they are said to be concurrent. So let's understand causal consistency model using an example. So consider three events: A equal to A plus 1, B equal to A into 5, and C equal to C into 3. So first two events are causally related to each other because B reads A after A was written. Okay, so B is reading A where A was written in the previous event. So these two instructions are causally related, while the third event C equal to C into C is concurrent statement because it is not depending on any of the updates that were done in the previous events. So it says that if an event X is an direct or indirect result of prior event Y, okay, so this is event X, which is an indirect or direct result of event Y, then Y should, then all processes should observe event Y first before observing event X. So let's understand with this figure. So you have, again we have four processes. P1 is doing a write operation on X, okay, and it's updating it to 8. Then it is this write, after this write operation has occurred, P2 is reading this value, same variable X, which has been updated by P1, and it is doing a write operation on X. So we say that these two operations are causally related, right? And now let's see WNXB and then WXC. So later on P1 is doing a write operation on X and P2 has already done write operation on X, but since they are not reading each other values, we say that these two are concurrent. So causal consistency model says that the causal events should be executed in the same order. Okay, first event X and then Y, while concurrent events can be executed in any order. So if we see P3 is reading C and then B. So first it is reading C and then B, while P4 is reading B and then C. So this concurrent events can occur in any order. So we say that this model is causally consistent. Let's see one more example under causal consistency. So now we have P1 doing a write operation on X, then later on time P2 is doing a read operation on X and then write. So we know that these two are causally related to each other. Now later when P3 is doing a read operation on X, it is first reading B and then reading A. Similarly, P4 is reading A and then B. So we see that this is not getting executed in the same order. So first WXA should have been executed and then WXB because B is causally related to WXA. So since that order is not being executed by P3, this is a violation of causally consistent data store. Let's see one more scenario. So P1 is doing a write operation on X and P2 is doing a write operation on B. Since there is no read operation in between, so these two are concurrent. So the operations can be seen in any order. So P3 reads B first and then A, P4 reads A first and then B. So since this is allowed, concurrent events can appear in any order, we say that B is causally consistent. Now coming to the next model, which is first in first out consistency model, which says that writes done by a single process are seen by all other processes in the order in which they are issued. But writes done by different processes may be seen in an order, in a different order by different processes. So what it says is, if consecutive writes are done by a single process, that same order should be maintained in our other replicas. Okay, so let's understand this with an example. So we have four processes P1, P2, P3 and P4. P1 is doing a write on X, P2 is doing a read on X and doing two consecutive writes are happening at P2. So first B and then C. So now if you see these two events, two writes from a single process, writes done by a single process are seen by all other processes in the same order. So in all other processes, first B should appear, then C. So in P3 first B is appearing, then C. In P4 first B is appearing and C. Okay. While these reads can be interleaved by other write operations in any order, but the order of writes of the same process should appear in the same order. So that's why we say this is satisfying FIFO consistency. So FIFO consistency is interesting and it is easy to implement. So just for understanding of how much you have understood, try to answer this question. Which data-centric consistency model is satisfied in a given figure A? So either it's strict, sequential or linearizability. So I give you a minute to think and then you. Okay, so I hope you have written the answer. The answer is B, sequential consistency, because the same order of operation should happen in all the replicas. So right x A and right x B are the events, while in P3 and P4, first right x B has happened, then A. In P4 also first B has happened, then A. Okay. Okay. One more question. Which data-centric consistency model is satisfied in figure B? So you can think and write your answers in your book. Okay. So I hope you have written it as D. So this is causal consistency because these two events are concurrent and they can appear in any order, while other three consistency models are getting violated. So in this video, we learned uh, various data-centric consistency models and we focused on linearizability, causal and FIFO. So this is the reference. Thank you.